Hello everybody. So today we're working on lesson 7.11 on page 307 of the third grade textbook. Our topic today is order of operations. And the essential question that we should be able to answer by the end of the lesson is, why are there rules such as the order of operations? So let's go ahead and start looking at the investigate for today. You can use what you know about acting out a two-step problem to write one equation to describe and solve a two-step problem. So if you solved a two-step problem in a different order, what do you think might happen? Well, I might get different answers, is what I think. So, for instance, here we have a two-step problem where it's asking us 4 plus 16 divided by 2. I see two operations there, so that must mean two steps. So make a list of all the possible orders you can use to find the answer to 14 plus 16 plus 2. Well, let's see. I guess I could, one way I could add, then divide, right? I would be just going left to right, add, and then divide. Another option could be, let's see, how about if I divide first, then add? Okay. Part B, use each order in your list to find the answer. Show the steps you used. All right, so this first one, 4 plus 16 equals 20, right? 16 and 4 more is 20. And then the next step, I still have to divide by 2. 20 divided by 2. 2 times what is 20? 10, right? 10. Okay. 2 times 10 is 20, so 20 divided by 2 is 10. All right, so that's what we got when we add first and then divide. 2, let's divide first, then add. Divide first. So 16 divided by 2. 2 times what is 16? 8. All right. And now let's add 4 plus 8. Okay. So we divided first. 16 divided by 2 is 8. And we still have to add the 4. So 8 plus 4 is 12. Did following different orders change the answer? Well, yeah, I got 10 and I got 12. If a problem has more than one type of operation, how does the order in which you perform the operations affect the answer? Well, what happened? When we changed the order, resulted in different answers, right? So if you added first then divided, we got 10. If we divided first and then added, we got 12. So the order in which you perform the operations affects the answer because it gives you a different answer. Explain the need for setting an order of operations that everyone follows. Okay, that makes sense, right? If everybody just did this operations any way they wanted, we would never have the same answers. So if we have a set order of operations, everybody will get the same result. Okay, so if we have the same order of operations or a set order of operations, we'll get the same result. At page 308. So when solving problems with more than one type of operation, you need to know which operation to do first. A special set of rules, called the order of operations, gives the order in which calculations are done in a problem. So in third grade, our order of operations, we're not covering them all. I do want to go ahead and just mention them all, okay? Because you'll probably see these, and I want you to be at least familiar with them. In third grade, we're just working with multiplication, division, addition, and subtraction as far as the order of operations. But you might hear somebody say the phrase, for order of operations, please excuse my dear Aunt Sally. Okay? And if you take the first letter of each of those words, you'll get something called Pemdas. Okay, that's the order of operations. Now, I don't actually like to have my students go left to right with this idea. Okay, I prefer to see it written like this: P parentheses first. Okay, so that's the most important thing in math. If there's parentheses symbols, we have to do whatever's in those first. And then that would be followed by something called an exponent. Okay? And in third grade, we don't deal with exponents, so that's why on our page it started with multiplication. Now on the next one, we're going to say multiplication or division left to right. Okay, so if we get down to a problem and we only have multiplication and division, we're going to do left to right. All right, and then our last level, we would add or subtract left to right. Okay. So parentheses first, exponents second, multiplication or division left to right, and finally addition or subtraction left to right. And when everybody follows these steps or these operations in math, we'll get the same results. Okay, otherwise we'd have kind of chaos in math. We'd all have to come up with different answers. Okay, so keep that in mind. The idea of PEMDAS with parentheses first, followed by any exponents, multiplication or division left to right, and addition or subtraction left to right. Okay, so we're going to practice the two bottom levels here in third grade. So it says first, multiply and divide left to right. Then add and subtract left to right. So let's look at our first problem as an example. Megan buys 2 books for $4 each. She pays with a $10 bill. How much money does she have left? Well, we can write our 2 steps together. We have $10, and we're going to subtract from how much she paid for these objects. So 10 minus 2 times 4, because she bought 2 books at $4 each, equals the cost. And so that's what we would use to describe and solve the problem. So use the order of operations to solve 10 take away 2 times 4 equals some unknown number. So remember, step 1, we will do any multiplication and division in the problem left to right. Okay, so here I don't see any division in this problem, but I do see multiplication. So I'm going to do the multiplication before subtracting. So 2 times 4 is 8. So then we're just going to rewrite it as 10 take away 8. So we're going to eliminate one operation at a time. So this first operation was 2 times 4. So now we have 10 take away 8. Well, that's fairly simple. We only have one operation left, so we have to subtract. So 10 take away 8 is 2. So she has $2 left. Does your answer make sense? Well, 2 books would be $8 if they are $4 each. 4 plus 4 equals 8. If she got $2 back, then 2 plus 8 equals 10. Yes, our answer makes sense. All right, so now on the next steps, we're going to be writing whether the directions that they're telling us to multiply, add, subtract, or divide, the order in which they are telling us, is correct or not. If it's correct, we're just going to say it's correct. If it's not correct, we're going to fix it. So, do you multiply and then add? Yeah. First, multiply and divide. First, multiply and divide. Then do any addition and subtraction. So, multiply first and then add. Yes, that's correct. 2. 8 divide by 4 times 2. Well, okay, so here, first thing was multiply and divide left to right. In our problem here, we only have multiplication and division. So if that's all I have, I go left to right. Well, if I'm going left to right, then I would divide first, then multiply. So we need to say divide, then multiply. Okay, so number 2 is incorrect. Oh, I don't know why I put an N there. Divide, then multiply. Okay, number 3, we have addition and division. Maybe we can even circle them and just get an idea of this. Division is above addition and subtraction. So this should be first, and this would be second, right? Okay, so it's M and D left to right, addition and subtraction left to right. Okay, so kind of you do this line first, then followed by this. So this is incorrect. They want us to add first, then divide. That's not correct. We have to divide, then add. Okay, number 4, I see addition and multiplication. All right, again, multiplication and division left to right first, then any addition and subtraction. So I can't add first. I have to multiply first. So this multiplication should be first, addition second. In the next one, we have addition and division. Multiplication and division comes first, followed by addition and subtraction. So division should be first, then add second. So this one's correct. This one, number 6, we have subtraction and multiplication. Multiplication and division, left to right first, followed by addition and subtraction. So multiplication first, subtraction second. So this one's correct too, because they're telling us to multiply first and then subtract, and that's correct. Multiplication comes first in the order of operations. All right, now number page 309, number 7. Now we're going to solve these using the order of operations. So we have division and subtraction, multiplication and division, left to right, then add and subtract, left to right. Okay, so division is on the same kind of math level as multiplication. So these two have to come first, followed by addition and subtraction. So the division will be first, the subtraction will be second. All right, so 63 divided by 9. Let's do that first. 63 divided by 9. Well, 9 times what is 63? We know that the factor that we multiply by 9 will be 1 greater than the tens place of the product. So if the tens place is 6, the factor that I multiply by 9 would be 7. So 63 divided by 9 is 7. Then we still have subtraction left. So 7 take away 2 is 5. So if your answer came out to be 9, you didn't follow the order of operations. You subtracted first, and that would be incorrect. You have to divide first. All right, number 8. We have subtraction and addition. Okay, so those are my two operations, subtraction and addition. When I only have addition and subtraction, I just go add and subtract left to right. So we're just going to go left to right. 7 take away 5 plus 8. 7 take away 5 is 2. 2 plus 8 is 10. Okay. So I know here in this, you might get confused and say, oh, but add comes before subtraction. No, think of them as equals. And when that's all we have in a problem, addition and subtraction, we're going to go left to right. So whatever comes first, when you have addition and subtraction in the problem, you do that operation. So here we have subtraction first, so we're going to do it. And then we're going to add. Okay. All right. Number 9, we have multiplication and we have subtraction. Okay, so multiplication and division, left to right first, then subtract. So 3 times 6 minus 2. So we're going to multiply first. 3 times 6. 3 sixes. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. Okay, so 18. Now minus the 2. 18 take away 2 is 16. Okay, this is where memorizing your multiplication facts comes in helpful. It's going to be much easier just to be able to say 3 times 6 is 18 than possibly have to use some of the strategies we've learned in this chapter. Okay, I could draw 3 circles and put 6 in each circle and get 18. But again, it's much easier just to say 3 times 6 is 18. All right, number 10, we have subtraction and division. Okay, so division is above addition and subtraction. So first we're going to divide. 80 take away 64, divide by 8. 64 divided by 8. Well, 8 times what is 64? 8 times 5 is 40. 8 times 6 is 48. 8 times 7 is 56. 8 times 8 is 64. So 64 divided by 8 is 8. And we still have to subtract. So 80 take away 8. Well, we know we can't take 8 from nothing. So we'll have to regroup this 8 tens as 7 tens and 10 ones. 10 take away 8 is 2. So 72. Okay. So if you wind up with an answer of 2 for number 10, you subtracted first. And you need to divide first. Number 11, multiplication and addition. Well, multiplication is above addition. Okay, so we're going to multiply first, then add. Okay, so 3 times 4, 3 sets of 4. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. 12, now we're going to add the 6. So we multiplied first, now we have to add. 12 and 6 is 18. If you got an answer of 30, you added first, and that would be incorrect. We have to multiply before adding. Number 12, we have multiplication and we have division. Okay, so they're on the same level, so we just go left to right. Left to right. 2 times 7, divide by 7. So multiplication's first, followed by division, because we're just going left to right when all we have is multiplication and division. 2 times 7, 14. 14 divided by 7, 2. 2 times 7 is 14. So our answer is 2. Now, this one, if you did divide first and then multiply, you would get the same answer, because 7 divided by 7 is 1, and 2 times 1 is 2. But that doesn't always work that way. Okay, so if all we have is multiplication and division, make sure we go left to right. All right, so now we have to practice these ideas to see if we can come up with the right answer by putting the operations together. So we know that we have to multiply first, followed by addition. So if I do 2 times 6, because that's first, okay, right? If I put the 2 and the 6 here, let's try that. So I'm saying if I put 5 plus 2 times 6 equals 16. Is that right? Well, if we multiply, 2 times 6 is 12 plus 5 equals 16? No. 17 does not equal 16. So it's not 2 times 6. But what if we try 6 plus 2 times 5? Does that equal 16? 2 times 5 is 10, and we still have to add the 6. Does 10 plus 6 equal 16? Yes. So our order is to go 6 plus 2 times 5. It actually doesn't matter which order we put the 5 and the 2, because we're going to multiply anyway, and 5 times 2 is 10, or 2 times 5 is 10, so it doesn't matter. Okay, so you might have to try some different combinations to get the answer. All right, in this next one, we're using 4, 12, and 18. We have a division problem and a subtraction problem. So we're going to divide first, and then subtract. All right, so 12 divided by 4 is 3, right? Because 3 times 4 is 12. And actually, when I look at that, that's the only one that I can actually divide evenly. Because 4, when I count by 4s, I never say 18. 4, 8, 12, 16, 20. Yeah, I don't say 18. So it's got to be 12 and 4. And the order of those two does matter. The 12 has to come first. The dividend must be first. 12 divided by 4. And so what's our only other number left? 18. So let's see if that's right. 12 divided by 4, we said is 3. 18 take away 3 is that 15. Well, you take a 3 is 5. Yeah, so 15 does equal 15. Right now in number 15, we have 8, 9, and 7. We have multiplication and subtraction. We have to have a multiplication problem first, and then we're going to subtract second. And we need to come up with an answer of 47. So, we can do 8 times 9. We can do 9 times 7. And we can do 8 times 7. I'm thinking I like 8 times 7 because that's closer to 47. Let's try that. 8 times 7. 8 times 7 minus 9. What is 8 times 7? 8 times 5 is 40. 8 times 6 is 48. 8 times 7 is 56. 8 times 7 is 56, and then we'd have to subtract. Well, what's 56 take away 9? Can I take 9 from 6? No. So I'll regroup the 5 tens as 4 tens and 10 ones. Now we have 16 ones. 16 take away 9 is 7. 4 take away no tens is 4 tens, 47. So that's what we wanted. All right, so that'll work. 8 times 7 minus 9. If you put 7 first and then 8, it's not going to affect your answer. Okay? Because no matter what, we have to multiply those two numbers together. And commutative property of multiplication tells us that the order in which the factors are written or multiplied doesn't affect the product. Okay. All right, and our last one. Okay, so we have division followed by an addition problem. So we know we have to divide first and add second. Well, let's see, which one of those would work as a division problem? 4 divided by 2? You could do that, right? 4 divided by 2, that's 2. Could I do 9 divided by 4? 4, 8, 12. No. So this is what I'm saying. 9 divided by 4. That doesn't equal 2. Or I mean, we can't divide 9 by 4 evenly. So that doesn't work. I can't divide 9 by 2 either. 2, 4, 6, 8, 10. I never say 9. So the only division possibility is 4 divided by 2. All right, so 4 divided by 2 is 2. Plus what is 11? Well, we've already used the 4 and the 2. It's got to be 9. Okay. Now, on the division, remember, the dividend does matter which one we write first. 4 must be written first. That's the dividend. I'm taking my 4, whatever it is, 4 of something, and I'm dividing by 2 groups, in a sense. That left me with 2 plus 9 equals 11. And 9 plus 11 is 11. All right, pose a problem. Write a problem that can be solved by using 2 times 5 divide by 5. So here we're going to multiply first and then divide, okay? Because we have multiplication and division. They're at the same level, and so we just go left to right. All right, so 2 times 5 divide by 5. Okay, so let's see. Hector bought 2 packs cars. Each had 5 cars in the pack. He then shared them equally with 5 friends. How many cars did each friend get? So here's my thought on that. I'm buying 2 sets of something and there's 5 in it. So that would account for the 2 times 5. And then I need to share them because it's division. I need to share them equally. And in this case, I said with 5 friends. So how many cars did each friend get? So if we're following this, it would be 2 times 5 divided by 5. So multiply first. 2 times 5 is 10. Divide by 5. 10 divided by 5 is 2. So each friend would get 2 cars. All right, number 18. Is 4 plus 8 times 3 equal to 4 plus 3 times 8? All right, so let's rewrite them. Okay, we got 4 plus 8 times 3. What comes first? Multiplication. And then addition would be second. All right. In the other one, we have 4 plus 3 times 8. Okay, well, in that one, which one do we do first? We do multiplication. All right, so multiplication first, followed by addition. All right, so no matter how they've written it, we have to do the multiplication part first. In the first one, we're doing 8 times 3. In the second one, we're doing 3 times 8. Well, aren't those two equal? Yeah, they're the same factors. They're just in different order. And then we would add 4. So yes, they are equal. Yes, because we have to find it without finding the answer. So yes, because 8 times 3 is the same as 3 times 8, and then both would have 4 added to it. 4 added to the product. Page 19. Page 310, number 19. 19A through 19D, select true or false for each equation. All right, so is 24 divided by 3 plus 5, 13. Well, division is above addition, so we're going to divide first and then add. 24 divided by 3. 24 divided by 3 plus 5. What is 24 divided by 3? 3 times 5 is 15. I'm going to start there. 3 times 5, 15. 3 times 6, 18. 3 times 7, 21. 3 times 8, 24. Okay, so 24 divided by 3 is 8 plus 15. 15 plus 8. 8 and 5 is 13. Regroup that as 1 10 and 3 ones. 1 and 1 is 2 tens. So 23. Yes, that is a true statement. 19b. 5 plus 2 times 3. We need to multiply first because it's above addition. So multiply, then add. 3 times 2 is 6. Now add 5. Is 6 plus 5 21? No, 6 plus 5 is 11. So 11 does not equal 21. So that's false. 15 minus 3 divided by 3. We need to divide first, then subtract. 3 divided by 3 is 1, and 15 take away 1 is 14. Okay, so 3 divided by 3 is 1. Now we're going to subtract 15, take away that 1 is 14. 14 does equal 14. True. And then the last one, 18 divided by 3 times 2. Okay, so we have multiplication and division. So we go left to right. 18 divided by 3 is 6. Now we have to multiply by 2. Is 6 times 2 12? It sure is. So 6 times 2 is 12. That's true. All right. Connect to social studies. Okay. Picture book art. The Eric Carle Museum of Picture Book Art in Amherst, Massachusetts, is the first museum in the United States that is devoted to picture book art. Picture books introduce literature to young readers. The museum has 3 galleries, a reading library, a cafe, an art studio, an auditorium, and a museum shop. The exhibits change every 3 to 6 months, depending on the length of time the picture art is on loan and how fragile it is. The table shows prices for some souvenirs in the bookstore in the museum. All right, so if I wanted to buy a picture frame, Firefly picture frame, it cost me $25. Exhibition posters, $10. Caterpillar note cards, $8. Caterpillar pens, $4. And Sun notepads, $3. Okay. Callan bought 3 Caterpillar note cards and 1 Caterpillar pen. How much did he spend on souvenirs? Okay, so 3 note cards and 1 Caterpillar pen. So we're going to go 3 times the cost of the note cards. The note cards cost $8. So he's buying 3 of them. So we're going to go 3 times 8. And he bought another item. He bought a Caterpillar pen, and those cost $4. Okay, equals, and we're going to say C. Okay, so he bought 3 sets of note cards and a pen. So we have multiplication and addition. Multiplication is above addition. So we're going to multiply first, then add. 3 times 8. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. So he spent $24 on the note cards. And now we have to add the $4 that he spent on the pens. So 24 plus 24 plus 4 equals the cost. And 24 plus 4 is 28. So $28 was spent. And number 21. Rhea and 4 friends bought their teacher one Firefly picture frame. They shared the cost equally. Then Rhea bought an exhibition poster. How much money did Rhea spend in all? Okay, so Rhea and 4 friends. So they're sharing the cost 5 ways. They bought one picture frame. Then Rhea bought an exhibition poster. So let's start with the frame. How much did they buy the frame for? They bought it for $25. Okay, so they spent $25 on the frame. They're sharing it 5 ways. So Rhea is one of those 5. So if I divide 25 by 5, I find out how much she spent on the picture frame. And then she also bought an exhibition poster, which costs $10. Okay, so $10. So 25 divided by 5 plus 10. So we're going to divide first and add second. And so that's going to equal, I'm going to say R for Rhea. I'm going to say that equals Rhea's cost. So let's do 25 divided by 5. 5 times what is 25? 5, 10, 15, 20, 25. 5 times 5. All right, so 25 divided by 5 is 5. So Rhea had to spend $5. That was her cost of the sharing for the frame that they bought their teacher. And then she spent an additional $10 on an exhibition poster. So 5 times 10 is $15. So Rhea spent $15. $5 on the frame plus $10 for the poster. All right, so that's it for lesson 7.11. The next time we get together, we will be reviewing for the Chapter 7 test. So until then, may the numbers always be in your favor.